Hello, and thank you for joining this session. My name is William Collins, and I am a Principal Cloud Architect for Alkira. Today, we are going to dive into a few topics which are getting a lot of attention across ONUG's working groups, and that is elastic networking and automation and orchestration. Both of these topics are important to both ONUG and Alkira because having a network that behaves elastically as businesses grow, this is a huge imperative for our customers in the enterprise space. And also, automation is no longer a luxury or a nice to have. Enterprises are working to modernize how their networks are provisioned and managed through automation. So today we will deploy a production-ready network that can scale elastically as the business grows, and we are going to do it with infrastructure as code. Before we get into the demo, let's lay out some requirements. We're going to be working in AWS and Azure specifically, so each cloud is going to get a dev, test, stage, and prod network. And Azure is going to get an additional migration network for sort of lift and shift migrations from on-premises. For communication requirements, dev, test, and stage, we want to allow them to communicate inside and across clouds, but prod, on the other hand, we want to keep prod isolated. So while prod can talk to prod inside and across clouds, prod should not be able to reach dev, test, and stage. Migration landing zone in Azure, this should only be reachable via the on-premises networks where workloads are being migrated from. And we're going to do that over Viptela SD-WAN. And as far as internet is concerned, dev, test, and stage, we're going to allow them to access internet directly. While prod, migration, SD-WAN, and IPsec networks, we want those to transit Palo Alto VM series firewalls in Alkira before egressing to the internet. Let's go through our network topology now so we can get a good visual of what we aim to deploy. So to start off, we will provision what we call a cloud exchange point, or CXP. And you can think of this like a virtual point of presence. And to meet the requirements in the previous slide, we're going to use Alkira groups, and these operate as the building block for microsegmentation in Alkira. They're global in scope, and they're going to work for everything that we connect back into the platform. And for internet egress, we're going to deploy an internet connector and auto-scaling Palo Alto VM series firewalls to steer, some of our critical traffic through, like production, migration, or even our SD-WAN and IPsec sites. And now that we have that foundation in place, we can go ahead and connect our SD-WAN fabric, our IPsec sites, and our AWS and Azure cloud networks. And now that we have everything connected, we're going to go ahead and enforce all the requirements on the previous slide with Alkira's intent-based policy, which is also defined in our infrastructure as code. Let's do a quick overview of the workflow. I have two Git repositories set up, one that holds the infrastructure as code for all of non-prod and the other for prod. Each repo maps back to a workspace in Terraform Cloud. I've already committed the infrastructure files to a develop branch in Git. So what's going to happen is I'm going to open up a pull request and merge the code from my develop branch to the main branch, which is going to mirror our hypothetical production environment. This is going to automatically trigger CI/CD, and then Terraform's going to provision any new changes to the infrastructure. In our case, for this go around, it's going to be all the changes. Let's go ahead and get started. So as we can see here, we don't have any infrastructure provisioned at this time. We don't have any networks connected. And if I go through and look at some of the configuration, I can see that We don't have any segments. We don't have any groups. We don't have any policies. We don't have anything. Okay, so let's go ahead and flip over to GitHub now. I see my non-prod repo here, and I see my prod repo here. And I already went through and created these pull requests. I just have to submit them. And to give an example of some of this infrastructure as code, this block right here is going to create my production groups. It's pretty simple. I'm just defining them in a list and then looping through them. And let's take a look at something else. Let's say connecting our Azure VNets. So this is simply connects both of my Azure VNets for prod, the prod and the migration VNet. Pretty simple. And as we can see in Terraform Cloud, I have my non-prod workspace and my prod workspace. Let's go ahead and merge that code. So we'll be doing non-prod first. So I'm going to go ahead and create that pull request. Merge. And we should see Terraform Cloud come to life now. Plan queued. It's running the plan. Let's take a look at some of these details. So these are all the resources that we're creating for our non-prod environment. And now it's going through and it's actually applying that infrastructure. All done. That was quick. Let's go ahead and pop over to the Alkira design canvas and do a refresh. And here we have all of our non-prod networks. Let's go ahead and do prod now. So again, we're going to create that pull request, merge it, go back to workspaces in our Terraform Cloud dashboard, and we see prod coming to life. And it's going to be the same thing. It's just going to do a plan and an apply. Done. Now let's go ahead and go back to our design canvas again and do a refresh. Okay, there we see our prod networks, and we also see the addition of our Palo Alto VM series firewalls that are set to auto scale, and then both our SD-WAN fabric and then our IPsec connectors as well. Now that we have the network up, let's do a little exploring. So if I look at the configuration here, I can see all the groups that I created for micro-segmentation. And one of the awesome things about using Alkira is the integration with other products that enterprises are using. So one example would be our cloud agnostic segmentation and being able to use that with Palo Alto security zones for single or multi-cloud workloads. So if I open the Palo Alto configuration, I can see these zones down here, and I have one created for on-premises that I have my IPsec and my SD-WAN group added to. For the last leg of this demo, I want to make sure that we hit on all of our requirements. So let's go through and visualize our policies. And for non-prod, dev, test, and stage, we wanted them to be able to communicate with each other inside and across clouds. And we wanted internet egress for dev, test, and stage to be direct, so that traffic wouldn't go through next-gen firewalls. So we can see there that our non-prod networks can indeed talk within the same cloud and across clouds, and that exiting to the internet doesn't go through the next-gen firewalls. Our prod requirements differed a little bit from non-prod, in that we wanted prod networks to be able to communicate inside and across clouds, but we wanted no reachability to dev, test, and stage. And furthermore, we wanted to steer traffic through Palo Alto next-gen firewalls for internet exit. So we can see here that our production networks can indeed talk inside and across clouds, and that traffic does get steered through the Palo Alto next-gen firewalls for internet exit. For our migration zone in Azure, we outlined that this environment would be specifically for lift and shift workloads from on-premises. So for connectivity, we wanted to limit reachability to only the networks where workloads were being migrated from. Also, we wanted this environment completely isolated in the cloud with no connectivity to any other cloud networks. Now, this may seem impractical, but consider the following. Let's say that most of my other cloud workloads are, let's say they're modernized, and they use identity or other cloud native security features for added protection. But these lift and shift environments, well, they're going to have Active Directory services, they're going to have long-lived VMs, tooling for patching, all of which present many other attack surfaces. So I want to limit exposure on both ends. And as these workloads get migrated, I also want that communication between on-premises in this landing zone to transit the Palo Alto next-gen firewalls in the CXP. And here we go. We see that from my SD-WAN mesh, I can reach this landing zone, and that landing zone is completely isolated in the cloud. It can't talk to any other cloud networks. And all traffic between these 2 points is going to get steered through the Palo Alto next-gen firewalls. And lastly, we wanted our sites, both SD-WAN and IPsec, to transit our global backbone with Alkira for internet exit. And we wanted to steer that traffic through next-gen firewalls. So there's our SD-WAN internet egress policy. And here's our IPsec internet egress policy. Both of those policies, traffic is getting steered through the Palo Alto next-gen firewalls before exiting the internet. Thank you for joining this session. And in under 15 minutes, we connected 9 cloud networks across 2 public cloud providers. We connected numerous sites, both SD-WAN and IPsec. We set up microsegmentation and policy to enforce several practical requirements that enterprises are facing today. And we also use that policy to steer traffic to auto-scaling Palo Alto VM series firewalls before exiting to the internet. And all these things provisioned with infrastructure as code on a platform that was built for the cloud, that behaves like the cloud, and is delivered as a service. You can download these slides on the following GitHub link. And if you're curious, if you can build a global multi-cloud network in under 30 minutes, go on over and take the 30-minute challenge.